Good day, everyone. I am Princess El Pahantoy, and now I'm going to talk about nanotechnology. So, let's define first nanotechnology. So, the term nano refers to 1 billionth of a meter. So, it is a scale so small that it's difficult to comprehend. To illustrate the size of a nano object, a sheet of paper measures around 100,000 nanometers in thickness, and a typical hair strand measures between 50,000 and 180,000 nanometers in diameter. Nanotechnology is a field of science and engineering that involves designing, producing, and utilizing materials, devices, and systems at the nanoscale, which is the realm of 1 to 100 nanometers. And to put that into perspective, a human hair is about 80,000 nanometers wide. So here's a simple way to think about it. So um, imagine a tiny building block, which is a nanometer that is incredibly small, like a single atom or a few atoms clustered together. So by manipulating these blocks, the nanotechnology is about manipulating these tiny building blocks to create new materials and structures with unique properties. So why is nanotechnology important? So at this scale, materials behave differently, offering exciting possibilities for first, creating stronger, lighter, and more durable materials. Next, developing new medical treatments and diagnostic tools. Third, improving electronics and energy storage. And fourth, cleaning up pollution and creating sustainable energy sources. Nanotechnology is defined by the U.S. Foresight Institute as an emerging technology in which the structure of a matter is controlled at the nanometer to produce novel materials and devices that have useful and unique properties. The term nanotechnology simply means technology with the dimensions of less than 100 nanometers. It is also referred to as atomically precise technology or APT. Again, nanotechnology focuses on manipulating matter at this incredibly small scale to create novel materials and devices with unique properties. The U.S. Foresight Institute defines it as an emerging technology in which the structure of a matter is controlled at the nanometer to produce novel materials and devices that have useful and unique properties. Here are the key concepts of nanotechnology. First is nanoscale. So nanoscale, it means the realm of 1 to 100 nanometers where materials exhibit unique properties due to quantum effects and increased surface area to volume ratio. Next is nanomaterials. It is the materials with at least one dimension in the nanoscale range. Examples include fullerenes, nanotubes, nanocrystals, and dendrimers. Next is nanoparticles. So it is an isolated solid state objects with all three dimensions in the nanoscale range. Examples include gold nanoparticles, silver nanoparticles, quantum dots, and polymer nanoparticles. So, nanotechnology is a rapidly evolving field with the potential to revolutionize many industries and some of the world's most pressing problems. Why is nanotechnology important to learn? So first, it unlocks new possibilities. At the nanoscale, materials exhibit unique properties that differ significantly from their bulk counterparts. For example, gold nanoparticles can be used to create highly sensitive biosensors, while carbon nanotubes are incredibly strong and lightweight, making them ideal for reinforcing materials. By understanding these unique properties, it allows us to develop revolutionary applications across diverse fields from medicine and electronics to energy and environmental protection. Next, driving innovation and economic growth. So, nanotechnology has the potential to drive innovation and create new industries, leading to economic growth and job creation. So, as the field continues to grow, there is an increasing demand for skilled professionals who can innovate and apply nanomaterials in various industries. So, third, it addresses global challenges. Nanotechnology offers a powerful tool for addressing global challenges like climate change, disease, and resource scarcity. So it can be used to develop sustainable energy sources, it improves healthcare, and create more efficient and environmentally friendly technologies. Enhanced properties. So at the nanoscale, materials exhibit unique properties that differ significantly from their bulk counterparts the novel applications. So these unique properties lead to revolutionary applications across diverse fields. Let's say, for example, in the medicine field. So, nanomaterials can be used to deliver drugs directly to targeted materials, enhancing treatment efficacy and reducing side effects. They can also be used for early disease diagnosis and for developing new imaging techniques. Next, electronics. So, nanotechnology is revolutionizing electronics, enabling the development of smaller, faster, and more energy efficient devices. This includes transistors, solar cells, and even quantum computers. Third is energy. So, nanomaterials can provide energy storage and efficiency in batteries, fuel cells, and solar panels. Next is environmental protection. Nanotechnology can be employed to clean up pollutants. It also purify water and develop sustainable energy sources. The last one is economic growth. So, nanotechnology has the potential to drive innovation and create new industries, leading to economic growth and job creation. In essence, nanotechnology offers a powerful tool for manipulating matter at the atomic and molecular level. It unlocks a wide range of possibilities for improving our lives and addressing global challenges. Learning about nanotechnology provides a deeper understanding of the world around us. It opens up exciting career opportunities and it empowers us to contribute to a more sustainable and technologically advanced future. Let's delve deeper in the applications of nanotechnology. So, nanotechnology might seem like something out of a science fiction movie, but it's already woven into many everyday products. So, here are some examples. First, sunscreen, which is very useful for everyone. So, the nanoparticles of titanium dioxide and zinc oxide are commonly added to sunscreens. These tiny particles are highly effective at blocking UV radiation and feel lighter on the skin, making modern sunscreens much less thick and greasy than those of the past. Next is in our clothing. So, nanoparticles of silica are used to create water repellent and stain resistant fabrics. This is why water forms tiny beads on waterproof clothing that simply roll off instead of being absorbed. Silver nanoparticles are also used in clothings to provide antimicrobial properties, killing odor, causing bacteria, and reducing the need for frequent washing of clothes. Third is in furniture. Nanotechnology is used to make furniture more durable, stain resistant, and even less flammable. The materials used are the nano silver, copper, and zinc. It can protect furniture from pests and fungi. Pests and fungi. Carbon nanofibers can be added to foam to reduce flammability by up to 35%. Fourth is adhesives. So, nanotechnology has led to the development of stronger and more durable adhesives. Nanoglues can withstand high temperatures and even become stronger as the temperature increases. Fifth is car paint. Nanoceramic coatings are used to protect car paintwork from water, contaminants, UV rays, and even bird droppings. These coatings can last for several years. Sixth is the sports equipment. Nanotechnology is used to improve the performance of sports equipment. like the carbon nanotubes. It is used to make tennis rackets to for it to become stronger and lighter. Nanoclay linings inside tennis balls help retain air pressure, keeping the ball bouncing longer. Last is in computers. So, nanotechnology is essential for the development of smaller, faster, and more powerful computer chips. The latest generation of Intel's core processor technology is a 10 nanometer chip. So, are just few examples of how nanotechnology is already being used in everyday products. So, as the field continues to develop, we can expect to see even more innovative applications of nanotechnology in the future. So now let's proceed to the history of nanotechnology. So first is the Feynman's vision in 1959. So in his famous lecture called There's Plenty of Room at the Bottom, the physicist Richard Feynman envisioned manipulating matter at the atomic level. He proposed the possibility of building incredibly small machines and devices, sparkling the imagination of scientists and engineers. Feynman didn't have the tools to realize his vision at the time, but his lecture is considered a pivotal moment in the history of nanotechnology. It laid the groundwork for future research and development in this field. Next is the rise of microscopes in 1980s. The the development of powerful microscopes like the scanning tunneling microscope or the STM and the atomic force microscope or the AFM allowed scientists to visualize and manipulate individual atoms and molecules. These microscopes opened up a new world of possibilities, paving the way for practical applications of nanotechnology. So next is the birth of nanotechnology in 1980s to 1990s. The 1990s saw significant breakthroughs in our understanding of nanomaterials and their properties. Researchers discovered new materials like fullerenes, carbon nanotubes, and quantum dots, which exhibited unique properties that could be harnessed for various applications. So it is from theory to reality. The early nanotechnology research focused on understanding the fundamental principles and developing new materials. And as the field matured, researchers began exploring practical applications of nanotechnology in areas like medicine, electronics, and energy. Fourth is the rise of nanomaterials from 1990s to present. So the 1990s saw the rapid development of various nanomaterials such as quantum dots for display technology, titanium dioxide nanoparticles for sunscreens, and silver nanoparticles for antimicrobial applications. The commercialization and applications, the nanotechnology began to transition from the lab to the marketplace, with the products incorporating nanomaterials appearing in diverse industries. Next, or the last one, is the future of technology. For the continued innovation, nanotechnology continues to evolve rapidly with ongoing research focusing on areas like advanced materials, energy storage, quantum computing, and biomedicine. Nanotechnology is poised to revolutionize various industries, leading to new products, services, and solutions for global challenges. Nanotechnology is a rapidly evolving field with its history marked by groundbreaking discoveries, technological advancements, and a growing understanding of the potential to transform our world. It is a testament to human ingenuity and our ability to manipulate matter at the smallest scales. Nanotechnology involves manipulating matter at the nanoscale, which is the realm of 1 to 100 nanometers. And to achieve this, there are two main approaches. First is the bottom up approach, and next is the top down approach. When we talk about bottom up approach, it is the building from the ground up. So the bottom up approach involves assembling nanostructures atom by atom or molecule by molecule. It's like constructing a building brick by brick, starting with the smallest units and building upwards. This approach often relies on the principles of self assembly, where molecules or atoms spontaneously arrange themselves into desired structures based on their inherent properties and interactions. So, an example of this is imagine creating a nanostructure by carefully arranging individual atoms using a scanning tunneling microscope or the STM. So, this method allows for precise control at the atomic level, enabling the creation of highly intricate and functional nanomaterials. Next is the top down approach. So it is the shrinking down from larger structures. The top down approach involves starting with larger materials and progressively reducing their size down to the nanoscale. It's like carving a sculpture from of marble, removing material to create the desired shape. This approach commonly utilizes techniques like lithography and etching to pattern and modify materials at the nanoscale. So, an example of this is imagine creating nanowires by etching a thin film of silicon using a focused ion beam. This process removes particle from the silicon film, creating precise nano-sized wires that can be used in electronic devices. So, by choosing the right approach between the bottom up and the top down approach, it depends on the specific application and desired properties of the nanomaterial. So the bottom up is ideal for creating complex and highly functional nanomaterials, often with unique properties not found in bulk materials. Whereas the top down approach is more suitable for mass production and creating simpler nanostructures with specific shapes or patterns. However, both approaches have their strengths and limitations, and often a combination of both is used to achieve desired results in nanotechnology. So that's all for my topic regarding the definition, the history, and the novel applications of nanotechnology. I hope you learned something. Thank you.
Good day, everyone. I am Heaven Gale Timoyola, and today I am going to continue the discussion of my co reporters about the Nano World. So, the U.S. Environmental Protection Agency in 2007 categorized nanomaterials into four types. These are carbon based materials, metal based, dendrimers, and nanocomposites. Now, let's delve into these types. First, we have the carbon-based material. These are mostly made up of carbon in the form of hollow spheres, ellipsoids, or tubes. The hollow spheres and ellipsoids are referred to as fullerenes, while cylindrical ones are called nanotubes. This nanotechnology is often applied to bearing seals and brake pads for military vehicles. They're like tiny super strong building blocks made of carbon atoms. These structures are incredibly strong and lightweight, and they have unique properties that make them useful in many ways. Fullerenes are like tiny hollow soccer balls made of carbon. They're very strong and can be used to create new materials that are resistant to heat and wear. Carbon nanotubes are like incredibly thin, hollow tubes made of carbon. They're extremely strong and can conduct electricity very well. Because of their strength and durability, carbon nanomaterials are used in military vehicles to make bearing seals more resistant to wear and tear. This means that the parts that help the vehicle move smoothly will last longer. It also creates stronger and more durable brake pads that helps the vehicle to stop faster and more effectively. Now next we have the metal-based materials. Metal-based nanomaterials are tiny particles of metals that have special properties because they're so small. Imagine a tiny speck of gold or silver, so small you can't even see it with your naked eye. These nanomaterials include quantum dots, nanogolds, nanosilvers, and metal oxides such as titanium dioxides. Quantum dots are like tiny glowing lights. They are made of semiconductors, which are materials that can conduct electricity under certain conditions. Quantum dots are composed of semiconductor crystals with hundreds of atoms that can be manipulated to change optical properties. Quantum dots can be used in displays, solar cells, and even medical imaging. Nanogolds are specks of gold so small they're almost like dust. These nanogolds are used in electronics, medicine, and even cosmetics. They have unique properties that make them good conductors of electricity and heat. And they can also be used to deliver drugs or create sensors. Similarly to nanogolds, nanosilvers are tiny specks of silver. They're known for their antibacterial properties, making them useful in wound dressings, clothing, and even food packaging. Nanogolds and nanosilvers have important biomedical applications such as drug delivery and engineering and as biosensors. Metal oxides, particularly titanium oxides, have antimicrobial properties and may be used for water treatment and purification. Let's move to the third type, which is the dendrimers. These are nano-sized polymers built from branch units. The numerous chain ends of dendrimers may be manipulated to perform biochemical actions such as improving drugs and drug delivery. These are tiny branch tree-like molecules. They're made of repeating units that branch out from a central core, creating a unique spherical shape. The branches of these trees are called dendrons and they can be customized with, with different chemical groups. Dendrimers have many branches or dendrons coming off their central core. This gives them a large surface area which is useful for attaching other molecules. Unlike many other polymers, dendrimers have a very well-defined symmetrical structure. This makes them predictable and controllable. The many branches of a dendrimer can be modified with different chemical groups, making them adaptable for various applications. The branches of dendrimers can be used to carry drugs to specific locations in the body. This helps to improve drug effectiveness and reduce side effects. It can also be used for drug improvement that can improve the properties of existing drugs such as their solubility or stability. Now lastly, we have the nanocomposites. Nanocomposites are composite materials made up of nanoparticles put together molecule by molecule. These are added to the products to enhance mechanical, thermal, and flame retardant properties. They also have applications in energy storage and conversion. Nanocomposites are materials that combine nanoparticles with other materials to create something stronger, lighter, or more efficient. Nanocomposite is the combination of nanoparticles and matrix material, resulting in a new material with improved properties. Nanoparticles can make materials stronger and more durable, like adding steel reinforcement to concrete. It can also improve thermal properties. Nanocomposites can be better insulators, preventing heat loss or gain. It has flame retardancy, which certain nanoparticles can make materials more resistant to fire. Composites can be used in batteries, solar cells, and fuel cells to improve their efficiency and for energy storage and conversion. So that's all. That's the four types of nanomaterials, which are the carbon based materials, metal based materials, dendrimers, and nanocomposites. Each of these plays a unique role in the field of nanotechnology and has special properties that make them useful in various applications. Each of these nanomaterials offers unique advantages and can greatly improve the performance of products across various industries, from healthcare to electronics and energy. As research continues, the potential for these materials to revolutionize technology and improve our daily lives is significant. In simple terms, think of these nanomaterials as special ingredients that can make everyday materials stronger, smarter, and more efficient. That's all. Thank you.
Good day, everyone. I am Nova Mabel Dosa Tumarong, and today I will be discussing the application of the nanotechnology. So, this topic is a continuation of the group's topic. So, in the medical fields, nanotechnology is used in drug delivery techniques, particularly using a dendrimer. So, this is a type of nanostructure that can be designed and manufactured to carry different materials that can recognize disease cells, diagnose disease, deliver drugs, and report therapy outcomes. According to a study by David Ruth and Jade Boyd in 2017 at Rice University and Northwestern Western University, gold nanoshells are capable of delivering toxic doses of two drugs, namely the lapatinib and docetaxel, inside breast cancer. So, this highlights two key nanostructures, which are dendrimers and the gold nanoshells. So basically, the nanotechnology offers targeted drug delivery, improving treatment efficacy, and potentially reducing side effects by concentrating therapeutic agents precisely where they are needed. So dendrimers provide versatile platforms for various therapeutic applications, while the gold nanoshell, on the other hand, showcase a specific example of targeted cancer treatment. In first aid, a bandage that is waterproof, elastic, and able to dissolve in the skin over time was developed by the MIT team led by Karp and Langer. The bandage is composed of nanopillars that function similar to the feet of geckos that use chemicals interaction between the nanopillars and the biosurface. So the bandage functionality is based on its unique composition on the of nanopillars. So, nanopillars is a microscopic pillars that is used in a bandage for adhesion. And the gecko feet, on the other hand, is the inspiration for the bandages design known for their strong adhesion. Now, let us move on to the CNT based membranes. CNT based membranes are used for water desalination and nanoscale sensor to identify water contaminants. Since CNTs have surface with chemicals in one-dimensional structures, they are good absorbent of organic and inorganic pollutants, thereby aiding in the water treatment process. And the nanoscale titanium dioxide photocatalysis has the antibacterial that can be applied to a water and air treatment, anti-fogging, and self-cleaning. So, CNT-based membranes are important in water desalination and as sensor for identifying water contaminants. Their structures allow for efficient absorption of organic and inorganic pollutants, improving water treatment. And separately, nanoscale titanium dioxide photocatalysis provide antibacterial action and is useful to or for water and air purification, anti-fogging, and self-cleaning application. So, as mentioned earlier, we have the various application of photocatalysis of tin dioxide. So, we have water treatment, self-cleaning, antimicrobial, anti-fogging, and air cleaning. Photocatalyst of nanomaterial tin dioxide has been proven to have self-cleaning building materials that have super hydrophobic and super hydrophilic properties. Self-cleaning is achieved by coating semiconductor photocatalyst tin dioxide on glass, ceramics, or plastics, according to Benedicts and others in 2000. So tin dioxide also has antibacterial properties when exposed to ultraviolet light. So now, let's move on to the last part, which is the nanofilms. So nanofilms can be used in thin films to make them water repellent, anti-reflective, ultraviolet and infrared resistance, and scratch resistance. So they are used in the production of eyeglasses, computer monitors that rather, and even cameras to protect their surfaces. So in reducing environmental pollution, nanoscale materials that contain iron are used to remedy groundwater sites and other areas with hazardous waste. So the nanoscale zero valent iron has been shown to chemically reduce contaminants such as tetrachloroethene, trichloroethene, and cis-1, and then dichloroethylene. So I so this described two main application of nanofilms and nanoscale iron materials, which are improving the properties of thin films and environmental remediation. So, in short, it highlights the versatility of the nanomaterials, showing their use in both uh, consumer products and environmental cleanliness. So, I think that would be all. Thank you.